Alright, I'm giving find the duplicate number a go. So it's given an array of integers containing n plus 1 integers where each integer is in the range 1 to n inclusive. So here it's like 1 to 4, so there's 5 elements. And we got to find which one is not right. So there's only one repeated number and we have to return it. You must solve the problem without modifying the array and use only constant extra space. And so what I'm thinking here is I'm not allowed to use any extra, like copy this into like a set or a hash map or anything. I can't modify the array. So we know that it's between 1 and n inclusive. Let me pull up Paint. Get rid of my last problem. Alright. So what I'm thinking here is this is a list of len 5. Ooh. 1 second. Alright, we have a list of length 5, which means that we know that our top number n is equal to n, well, our length n, our top number will be n minus 1, which equals 4. So what is the properties of a array of length 4? I mean, up to number 4. Well, we know that it will add to, or 1 plus 2 dot 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 4 will equal 10. This is just the sum of the array, which is easy enough to get. And with our duplicated number, it's actually going to add to 12. So what we can do is sum like 4 plus n minus 1 plus n minus 2 plus down to 1, and grab this 10, and then we take our actual sum and minus this 10 from it. So we end up with 12 minus 10 is 2, and we can store these in just variables, which is constant space, pretty much. Now, I think getting this 10 is going to be a little easier said than done. The 12 is easy. We can literally just type sum and like sum of nums. So our actual val is sum nums. So if we return actual underscore val, for this first one, we should get 12 for our first test case. Output 12. Nice. So now we need to get our the val that we like are meant to have. Yeah. I guess we can call it target val, and we can set that equal to, we'll grab the length first actually. N is equal to len of nums minus 1. You can see that just up here. Our length is 5 minus 1, and that's what we're going up to. Whoopsies, didn't mean to do that. It's back over. I wonder if we could just do so without modifying the array and use only constant extra space. Yeah, that's fine. For I in range n, I forgot, is this inclusive? I feel like it's not. I'll just quickly print this, it doesn't hurt to check. One, two, three, it is not inclusive, so we can just get rid of that. And we can do target equals 0, target plus equals I, get rid of this, and we can do actual underscore val minus target. It's meant to be a val, but whatever. I think this should work, to be completely honest. If I submit this, I hope that works. That'd be good. Output 5, expected 3. Oh no. So the numbers aren't? Wait, I'm confused. Containing n plus 1. Ah, alright, this is a good lesson. Read all of the examples, not just the first one. So it doesn't have to be just one number out of place, I guess. They can, like, they don't have to be from 1 to n. It can be anywhere in that range, which makes this whole thing useless, which isn't great. So how would we do this? You could do some weird double loop where you do like for I in nums, for j in range I to len. If I equals j return. I might try that. This is such a nice answer for these two questions though. It's a little annoying that this is there to ruin that, but whatever. So we do for I in nums, do in range len nums. Then we will go for j in range I to len nums. If nums I equals j, nums j, return nums I. You could probably optimize a little here with, we'll see if this works first. Why would it be doing that? If nums I equals nums j, why on earth would that be returning? One three four two two, output 1 0 0. This looks like it's gonna time out. Okay. We could maybe even sort this and then do something like that. That might make it O(n) time complexity. Nums.sort. This double for loop's clearly not going to work when we have inputs like this, which means it needs a whole different method. This sorts it in place, which does nothing extra to the memory. Wait, oh, are we not allowed to modify it? Oh no. If we can't modify it, I'm genuinely not sure. We clearly can't use a double for loop. We can't use my target value minus the actual value because we can have all of the same number. I might just have to check the answer for this one. It'd be really nice if we could have modified the array, because then we could have just looped over once and checked our current value versus the next value. Might have a look at someone else's approach. I don't understand what this is doing. The index of nums fast. I don't understand this at all. For I in rangeland, if nums I in dictionary return true, else dictionary nums I equals 1. Is that not using, yeah, extra space? This one actually isn't allowed because we need to use constant space. I swear that's not right. Oh, what? Why am I on this page? Okay, yeah, back here. I think I went back to my previous solution. Binary search. How could this possibly work with binary search? Yeah, okay, we're not allowed to modify the list. Obviously this would work, yeah. But it does not work given the actual problem. It seems like a lot of people are just like not able to do. Yeah, okay, this guy's using extra spaces, like non-constant space as well. I think the only one that I saw that actually looked like it works is this one. Well, we didn't sort this. I'm gonna copy this answer and poke around for a little bit in it and see if I can just figure out what it's doing. Because this is the only one really that looks like it's working. So I'm going to print the fast pointer and I'm going to print the slow pointer and see what's going on here. So the actual pointers themselves are the values in the list, I believe. Slow equals num slow. Yeah, so we start with our slow pointer initialized on nums 1, which is 3, and then we start it on noms of noms fast. Well, noms fast is the same as noms slow, which is 1. And then noms 1 is 3. So fast becomes noms fast. Noms 1 is 3 and noms 3 is 0, 1, 2, 3. So 2. I'm genuinely so confused how this works. So the slow pointer equals the fast. And then we make a new pointer, which is also equal to num0. And then while pointer doesn't equal this, pointer equals nums pointer, and fast equals nums fast. Yeah, I've got literally no clue how this works. Gonna dig into this one, figure out what's going on, but I think that's enough for right now.